stimulation of alpha receptors causes degranulation, contraction of the smooth muscles, but blood vessels are constricted. But whenever there is a stimulation of the beta-adrenoceptor receptors, that suppresses degranulation. There is a relaxation of the smooth muscles, but the blood vessels get added. So epinephrine mainly works through the beta-adrenoceptors, but it can also bind to some extent to the alpha-adrenoreceptors. But mainly it works by lessening the degranulation and constriction of the smooth muscles. I mean, smooth muscles will be relaxed, so the patient will have advantage of breathing better. Hypersensitization, again, injecting. Once you identify the allergen that's causing the problem, you can do these allergy shots or hypersensitization. What exactly we are doing? You are injecting the offending allergen in increasing doses over a period of time. And you will see some benefits of that. But mainly, how does it act? Question.
I was wondering, what's the difference between injecting over a prolonged amount of time to begin the hypersensitization process, and if an animal was exposed to the allergen for a prolonged amount of time but is still experiencing atopic dermatitis?
In that case, it could be a problem, but over a period of time, as you increase the doses, it will produce a lot of IgG type antibodies, so it will block eventually. Initially, it might, in that case where you see mainly atopic dermatitis, it might be a problem. But animals with allergic asthma and all those things, you will have definitely better. But as again, remember, atopic dermatitis is not always necessarily due to injected allergens. Okay, it could be inhalant or ingested. So that will definitely, you will see benefit there. Injected allergens causing atopic dermatitis, that's not a common thing to talk. But food allergens, inhalant allergens, that's the problem. So how exactly it's acting? Mainly by producing a lot of IgG type antibodies because of series of injections, booster response. You have a lot of IgG antibodies, and they will prevent allergen binding to IgE type antibodies. So it's a blocking antibody that will prevent allergen binding to the IgE antibodies and causing problems. But also, it might downregulate those Th2 type cells, Th2 type helper cells that will have some benefit, downregulate them, but also stimulate Th1 type cells. So that's also beneficial to the animal. We said cyclosporin is being used.
Did you say so it doesn't bind to IgE?
Yes.
Okay.
Let me go back, say again. Because of the series of injections, you are making the animal to produce a lot of IgG antibodies. Okay, those IgG antibodies, we call them blocking antibodies because they will block allergen binding to IgE antibodies. And once allergen binds to IgE antibodies, that's triggering mast cells, but now that's being blocked by IgG antibodies. Coming to the treatments for type 1 hypersensitivity, we said you can do that hyposensitization or allergy shots, but a lot of times we use kind of mild immunosuppressive agents. You can use prednisone, for example, corticosteroid. Cyclosporin, other immunosuppressive drug, is used in the brand name Atopica. That will help. Okay, that's all I need to say about type 1 hypersensitivity. We will not cover rest of the type 2, 3, 4. Maybe we will do that later. Any questions on type 1 hypersensitivity itself? So what are the other treatments? We said if it is an anaphylactic type reaction, we use epinephrine. And but most commonly we use antihistamines, right, to stop the type 1 hypersensitivity. But if it is atopic dermatitis, they have shown some benefit with cyclosporin. If you are okay with this one, then let me close this one and go to start with T cells. Regarding T cells, first thing is you remember naive T cells can be differentiated into Th1, Th2, or Th17, and T regulatory cells. It's kind of slow. All T cells have the T cell receptor on its surface with which they bind to the antigenic peptide that's presented by an antigen presenting cell. So again, always remember T cells do not recognize antigen by themselves, and a virus entering into the animal will be taken up by antigen presenting cells, and they will present processed antigen peptide in association with MSC class 2 antigens, and that will be recognized by T helper cells using its T cell receptor. Whereas a virus that's infecting a fibroblast, for example, will present antigenic peptide in association with MSC class 1 antigen, and that will be recognized by cytotoxic T cells, right? Again, remember which ones are express CD4, which ones express CD8. CD4 is expressed by T helper cells and CD8 by cytotoxic T cells. So again, remember that association, MSC class 1 is recognized by cytotoxic T cells. Okay. MSC class 2 on the antigen presenting cell will be recognized by T helper cells. It's not open. Again, you are seeing quickly the T cell receptor. One thing is most of the T cell receptors are alpha beta type polypeptide chains, and in most animals they are the most common in the peripheral blood. Whereas gamma delta type T cell receptors are mostly in the mucosal surfaces, except in ruminants. In ruminants, they also have more gamma delta type cells in the blood. Nothing much here. Just by the side of the T cell receptor, there is a molecule called CD3 with all those 3 chains, and it's expressed on all T cells. That's what you're saying here. But most importantly, remember these, the naive T cells can differentiate either to Th1, Th2, or 17, or T regulator cells, depending on the type of pathogen that's driving their differentiation. Th1 all that I want you to get, simply remember here, Th1 is mainly antiviral immunity. It's stimulating cell-mediated cytotoxicity, where cytotoxic cells kill virus-infected cells. That's an important mechanism for recovery from infections, right? Remember that. The most important mechanism for recovery from a viral infection is cytotoxic T cells killing virus-infected cells. So that's Th1. Th2 cells are mainly involved in parasitic immunity and also causing allergies, which you have seen in the previous slides. Th17 is mainly extracellular pathogens like bacteria and fungal organisms. But T regulatory cells is mainly downregulating overaction by any of these cells. Too much action by Th1, Th2, Th17 is downregulated by T regulatory cells. Again, don't have to say antigen presentation, antigen presenting cell, taking up the virus, breaking down peptides, but importantly, we should now remember it should be MSC class 2 molecule, and it's presenting that antigenic peptide which will be recognized by T helper cells, okay? Remember that it will be recognized by T helper cells, and then they do what? That's an important question. Th2 cell, T helper cells are recognizing these antigenic peptides presented in association with MSC class 2 molecules. And once they recognize, what do they do? T helper cells. They produce those cytokines which are required for stimulating the functions of all other immune cells. So remember that. Whereas a virus-infected cell will present antigenic peptide in association with MSC class 1. But here it's still dendritic cell, so it's MSC class 2 here. And this is a virus-infected cell, and it's showing those MSC class 1 molecules, and the antigenic peptide will be recognized by cytotoxic T cell, and then it will go ahead and kill this virus-infected cell. That's all written there, but nothing much here, don't worry about these here. So how exactly they kill, that's important to know. Once the cytotoxic T cell, shown here, has recognized the virus-infected cell, it has to go and kill it, and it will release those perforin molecules. You should remember that. Cytotoxic T cell releasing perforin, which causes channels or holes in this virus-infected cell. Then it releases those enzymes and causes damage to the cell. That's all about T cell mediated immunity. Fetal and neonatal immunity, I will not go into that, but you should remember about the failure of passive transfer. What exactly is it? Maternal antibodies coming either through the placenta in some animals, but in most animals it will be through the colostrum, right? Except in dogs and cats, there might be some 5% coming through the placenta, but still they also depend a lot on colostrum. In primates, of course, most of the maternal antibodies are go through the placenta, so when the neonatal animal is born, it will have IgG almost like its mother. Okay. And failure of passive transfer, we said if the levels are less than 800 milligrams per deciliter, then we call it at least partial failure. And if it's less than 400 milligrams, definitely failure of passive transfer. And we talked about the diagnostic tests. Maybe I will still open it. Diagnostic tests, remember that zinc sulfate turbidity test? Just to put a drop of serum or plasma into a tube containing zinc sulfate, and that will precipitate all the immunoglobulins and make the tube turbid. Then you compare it with the chart. So that's zinc sulfate turbidity test. Let me go through that quickly here. So again, what is the best time for the neonate to absorb those immunoglobulins? It's the first few hours. Usually we say first 6 hours after birth is the best time, but it will go on up to 24 hours, but then it shuts off. Nothing will, no immunoglobulins will be absorbed after 24 hours. Okay, so again, zinc sulfate turbidity test is the most rapid test, okay? And we can also use any of these single layer immunofusion or like hexagglutination or even there is a snap test, I said. In case of falls, you can use the ELISA-based snap test for confirming failure of passive transfer. But this is the one that's cheap and rapid. Okay. Any questions on this? So, once you recognize there is a failure as passive transfer, what can we do to the animal? She said feed colostrum by mouth. But we said nothing will be absorbed.
In foals, you can do a plasma infusion.
Yeah. See, feeding colostrum, say, will be okay because it will still have IgA type antibodies in the colostrum, which will protect the mucosal surface. So I would not say that's not recommended, but it will not absorb any IgG present in the colostrum. But it will be okay to feed colostrum even after second or third day. So that's why we freeze colostrum in the dairy farms or even equine situation. But injecting horse plasma or serum, if possible, from the mother, if not other animals. Any questions? Again, remember that maternal antibodies interfering with vaccination, and that's why we say best time to vaccinate small animals is around 8 weeks of age. You can, if you want, at 6 weeks of age, but it's commonly 8 weeks and then repeat at 15 weeks. Coming to the chickens, we said the IG, although it shows IgY, because the IgG is coming from the egg yolk yolk, that's why they put IgY, but that's coming from the egg yolk. But IgA is coming from the albumin. As the chick hatches out, it ingests that albumin, which has a lot of IgA. So when the chick comes out of the egg, it already has IgG, and immediately on the first day it will have IgA because it ingests that albumin. Okay. Zinc sulfate turbidity test, of course.
Dr. Reddy?
Yeah.
IgG and IgY are the same, just that IgY
Yes.
is chicks, okay.
Yeah, because it's coming from the, initially, because it's coming from the egg yolk, they put IgY, but nowadays they still call it IgG. Mucosal immunity, I will not probably go through this much, but again, remember, in most animals, mucosal surfaces are protected by IgA antibodies. But whereas in ruminants, mucosal secretions have more IgG. They might have a little bit IgA, but predominantly it will still be IgG. The other thing to remember in mucosal immunity, again, if you look at the upper respiratory tract, it will be mostly IgA. But as you go down into the lungs, it will be IgG. That's the same thing with the reproductive tract. Initially it will be IgA, but if you go